Alright, so we're going to look at 5.3, the quadratic formula. But first, let's solve this warm-up by completing the square. So we got x squared plus 12x, then we're going to add something in here, equals, we're going to subtract 4 for both sides to get our constant to the other side, and then plus something, that same something. So now we take our b, which is 12, divide it by 2, and then we square that 6. So we're adding in 36 to both sides. If you do it to one side of the equation, you have to do it to the other side of the equation. Then when we factor this first trinomial, what numbers multiply to 36 and add up to 12? Well, that's 6 and 6, so it's the same thing. So x plus 6 squared. Again, which is just x plus 6 times x plus 6. Negative 4 plus 36 is a 32. Now, we do the stuff we did last unit. Square root to get rid of the squared. So we get x plus 6 equals plus or minus root 32. Now, we probably want to simplify the root 32 at this point. Well, I'm lazy. I'll just tell you what it is made up of. It's made up of 5 2's. So we have a pair. We have another pair. But this guy doesn't have a pair. So it's x plus 6 equals plus or minus, and we got a 2 for this one, a 2 for this one, and then that 2 is still inside the square root. So multiply that 2 and the 2 on the outside, we get 4 root 2. Not done yet because we don't have x. We subtract 6. So that x equals negative 6 plus or minus 4 root 2. You could put the 4 root 2 first, make sure the plus or minus is in front of it, and that would work the same as well. So vocabulary in this next section, quadratic equations are ax squared plus bx plus c equals 0. That's what we've been doing pretty much the whole year. The quadratic formula tells us how to get zeros without factoring, without using the square root property, without completing the square. It's just a formula and you plug it in. So x equals negative b, or the opposite of b, plus or minus the square root of b squared minus 4ac, all over 2a. Now that square root to go all the way over to the c, and the discriminant itself is just b squared minus 4ac. It's the stuff inside the square root, and we'll get to why that's important in a second. So just real simple, you find a, b, and c, and you plug them into the equation, or into the formula. First thing we always need to do, though, we need to set the equation equal to 0. Then we find a, b, and c, substitute in the equation, and then order of operations. Alright, so first off, we have a equals 3, b equals negative 4, and c equals negative 9. So the sign in front of them goes with it as well. And we know a, b, and c. So we substitute that in, and when we do it, we get that. Negative 4 plus or minus the square root of negative 4 squared minus 4 times 3 times negative 9. Notice that negative 4 here is in parentheses because you're squaring the negative and the 4. Negative 4 times negative 4 is positive 16. This first term, this one right here, should never, ever, ever, ever be negative. When we square something, it becomes positive. So we substitute all that in, and then of course over 2a, so 2 times 3. you're going to get points just for substituting it in. So write out your work. Then we simplify. Well, obviously the negative 4 is positive 4. Negative 4 squared is 16. And we have minus 4 times 3 times 6. So that's 4 times 3, which is 12. And 12 times 9 is 108. And it's a positive 108 because we have two negatives, and when they multiply together, we get a positive number. And then 16 plus 108 is the 124 they got there. So it's not some kind of mystery. Then we can simplify the square root of 124. We know 2 goes into it because it's even. So 62 and 2 and 31. Oop. Let's keep those square roots over all the numbers. Well, the 2's we can't break down anymore. And the 31, no, we can't do anything with that either. That's prime. So we got a pair of 2's. And the 31's still in the radical, which is how we got that part. And then, for this last step, we simplified, we divided 3 terms by 2. The 4 divided by 2, the 2 divided by 2, and the 6 divided by 2. So we have 2 solutions, 2 plus or minus root 31 over 3. Not too bad. You may also see it separated like this. You can write them separately, one positive, one minus. It doesn't matter. So let's look at another one. How can you use the quadratic formula to solve x squared minus 9x plus 27? All right, so again, A is what's in front of the x squared? That's right, a 1. B is negative 9, and C is positive 27. So we substitute in. Negative 9 squared is 81. 4 times 1, of course, is just 4, times 27 is 108, but now it's negative. So 81 minus 108, negative 27. Of course, negative 9 in the front would be positive 9. We got 2 times 1 in the denominator. So from here, we need to simplify the square root of negative 27. Well, first off, that negative is going to come out. And again, maybe draw an arrow where it's supposed to go. So we take out the negative, we get our imaginary number, I. And we do our factor tree for 27. So we get 3 3's when we factor 27. So we got a pair. So 1 3 will come outside. Now this 3 does not have a pair. So that's how we got this. And then again, you can write them separately like this. I don't think it matters if you write it like this as well. So not too bad. So you just plug them in order of operations. So we got 2 more here. Let's write them out. A equals 2, B equals 6, C equals 3. And I'll write up our quadratic formula, negative b, or the opposite of b, times b squared minus 4 times ac, and all of that divided by 2a. So substitute in. And we need a new color. So negative 6. Notice when I substitute in, I put them in parentheses so I don't do some weird operations. Plus or minus the square root of b squared, so 6 squared, minus 4 times a, which is 2, times c, which is 3. And then all of that divided by 2 times a, which is 2 times 2. And then from there, we need to simplify it a little bit. So negative 6 is negative 6. Inside our square root, 6 squared is 36. 4 times 2 is 8, times 3 is 24, and it's minus 24. So we get root 12 here. And of course 2 times 2 is 4. Now, you cannot simplify that root 12 with a 4. The root 12 is all inside the radical. It can't come out and play with the 4. So we need to simplify that. So square root of 12, we're going to factor that. 4 and 3. And of course 4 is 2 and 2. So we bring a 2 out. So we got a pair. But we leave the 3 on the inside because it didn't have a pair. And that's over 4. Now, -6, 2, and 4 can all be simplified by dividing by 2. So our answer really is, oops, make sure I simplify. Let's write them down here. So divided by 2, so it'll be -3 plus or minus 1 root 3. We don't write the 1, so it's just root 3 over 2. And again, you could separate them like we did. I don't think we necessarily need that. Let's look at this next one, same idea. A equals 3, B equals -2, and C equals 7. Substitute them in. Negative B, so -2, plus or minus, square, come on, get out of here. Square root of b squared, so -2 squared, minus 4 times a times c. Sorry, technical difficulties. Don't forget about our denominator. It's 2 times a, and of course a is 3. So now we simplify. -2 is of course just +2. Now if we simplify this square root stuff, the thing inside the radical, -2 squared is a +4. Then 4 times 3 times 7. Apparently we got error on my calculator, so that's not good. I will try this one more time before I start getting angry. -84. So we got -80 inside the radical and 6 in our denominator. Now, of course, we can simplify the square root of -80. First, let's take out our I and poke it out. So we got an I. Then we do our factor tree. So it's an 8 and 10. Of course, 10 is 2 and 5. And you. Again, I like to cheat with 8. I don't know why. But it is 3 2's all multiplied together. So we have a pair of 2's, another pair of 2's, and then we got 5 still stuck inside the square root. So that kind of stinks. But we have 2 times 2, so 4i root 5. So 2 plus or minus 4i root 5 over 6. And again, we can simplify the 3 numbers, the 2, the 4, and the 6, all by 2. 2 divided by 2 is 1. It doesn't disappear. So 1 plus or minus 4 divided by 2 is 2. Still have I and the root 5 over 6 divided by 2 is 3. There's our solution. Well, not too bad if you go step by step. So let's continue on with our second example here. We're going to choose a solution method. See which one is faster, more efficient, easier, whatever we're looking for here. So we have the equation 6x squared minus 7x minus 20 equals 0. It equals 0, so we can use all the different methods that we've learned using 2 different methods. So one is a quadratic formula. -7 plus or minus square root of -7 squared minus 4 times 6 times -20 over 2 times 6. So it simplifies all the way down to 7 plus or minus 23 over 12. So 1's plus, so 7 plus 23 is 30. 30 divided by 12 is 5 over 2 as a simplified fraction. Now when we do 7 minus 23, we get -16, and 16 divided by 2 simplifies down to -4 over 3. So pretty straightforward, stuff that we can do, nothing crazy. But if we look at our factoring, even a nasty factoring like this, do our diamond problem. We got 6 times negative 20, so negative 120 and negative 7. Two numbers multiplied to negative 120 and add to negative 7 would be negative 15 and 8. So we get those two, and that's what we split these into. So 6x squared stays the same, minus 15x plus 8x, our new stuff, minus 20, still there. So we take out our GCF out of each pair, 3x out of the first one, we divide it out, we're left with 2x minus 5. We take a 4 out of the second set, we're left with 2x minus 5. These better be the same, or else you didn't factor correctly. Then we can factor out the 2x minus 5s, and what we have left is 3x plus 4. So when it's all factored, 3x plus 4 and 2x minus 5 equals 0. Well, I want you to do one more step, at least one more. Set each of those factors equal to 0. So subtract 4. 3x equals negative 4, divide by 3. That's how we got our first, negative 4 over 3. Second one, let's add 5. So we get 2x equals 5, divide by 2, and we get 5 over 2, the two answers here. Now, I think both of them are probably just as efficient. I don't think either one is easier than the others. So both solution methods give the same result. I hope they give us the same zeros. Factor may be more efficient, if you remember it, but the quadratic formula always works, regardless of whether the function has real or imaginary roots. And you can have ridiculous numbers as A, B, and C, and you don't have to do diamond problems. You don't have to do a whole lot with that. So if there's some bigger numbers, use the quadratic formula. Identifying the number of real number solutions. How can you determine the number and type of solutions for a quadratic equation? So if we graph it, anytime it crosses the x-axis are our roots. So we got one here and one here. I believe that is 1/2, and the next one is 3. So we have two solutions there. The second one, it just intersects the x-axis at one place. And it looks like, oh, yeah, it's right here. Negative 1.5 comma 0. One solution. And then this last one, well, we're above the x-axis and we're still going up. So we have no real solutions. Doesn't mean we have no solutions. There's always two solutions for a quadratic. So now, let's look at this from the algebra standpoint, using our quadratic formula. I'm not going to go through each little step here. Hopefully we can see how we got that. But we simplify our square roots. In this first one, we get 7 plus or minus 5 over 4. So 7 plus 5 is 12, divided by 4 is 3. 7 minus 5 is 2, divided by 4 is 1/2. And luckily, that's exactly what we said. Here, negative 12 plus or minus 0, which is 0. So negative 12 over 8, simplifies down to negative 3 over 2. And again, that's what we said it was. Negative 1.5 and negative 3 over 2, same thing. And lastly, we have negative 1 plus or minus I root 7. So we had a negative inside the square root. And that is why we have no real solutions. We have an imaginary solution, or solutions. So this is how this works. Actually, it just says the same stuff that we just did. So if we, well, let's keep looking. What we are looking at there is the discriminant. The radicand in the quadratic form is what determines the nature of the roots. So, not with the square root, but b squared minus 4ac, that expression that is inside the square root in the quadratic formula. Well, depending on the value, we can figure out something about the solutions. If b squared minus 4ac is greater than 0, meaning it's positive, we have two real roots. They may be irrational, they may be ugly, they may be nice, they may be integers. But we're going to have two, let's not say that. We're going to have two real roots. Now, if b squared minus 4ac equals 0, then we take the square root of 0 and we don't have anything, so the plus or minus kind of goes away, and that's why we only have one real root. Of course, that is when our discriminant is 0. If b squared minus 4ac is less than 0, so we're talking about a negative number inside the radical, then the equation has two non-real roots. So let's take a look at these ones. I believe, well, let's look at it first. So b squared minus 4ac, a is 16, b is 8, and c is 1. So 8 squared minus 4 times 16 times c. So 64 minus, and even your brilliant math teacher has to use a calculator, so that's okay. So 64 minus 64, oh, our discriminant is 0. So what does that mean? Oh, it means we have one real root. So let's find it. I believe that we can factor this one, so that's what I'm going to do. So 16 times 1 is 16, that's our product. The bottom number is our sum, the 8. So what are we looking at? Well, we're looking at 4 and 4. Now, unfortunately, this first coefficient is not 1, we can't do the shortcut. So we have 16x squared. Instead of 8x, we have a positive 4x and another positive 4x. Then, of course, we group them. We factor. So we take a 4x out of here. We're left with 4x plus 1. That last term does not disappear. 4x divided by 4x is a positive 1. Then we can't really take anything out of 4x plus 1. But we can always take out 1. It's just kind of boring and not as useful. So now we have 4x plus 1, which we should have. We factor that out. Oh, and we got another 4x plus 1. So even though we have two sets of parentheses, they're going to give us the same answer. So 4x plus 1 equals 0. We subtract 1. 4x equals negative 1 divided by 4, and x is negative 1/4. We had one real solution, just like we thought. Now, if we look back at letter B, maybe this time let's use the quadratic formula. I'm not sure you can factor that one anyways. Ah, you can. So first, let's look at our b squared minus 4ac. Find our discriminant and tell us about the types of answers. So b squared, negative 5 squared, in parentheses, minus 4 times a times c. Notice again, there's no square root with that. We're not looking at the square root. We're just looking at that radicand inside of it. So we get negative 48 or minus 48. So we have negative 23 as our discriminant. So that means we have two, they say non-negative, too imaginary, too complex, whatever. So can we keep going? Yeah, of course. So our full quadratic formula is negative b, so negative 5, plus or minus the square root of b squared minus 4ac, which we know is negative 23, all divided by 2 times a. So negative 5 is a positive 5. We can't simplify 23, but we can poke out our negative to make it an I. So poke out your I. We got I root 23 over 4. Can't simplify that. So we have two imaginary solutions because we have an I, and that's what we thought anyways. So let's continue on. Now we got a word problem. Rachel's about to serve and toss a tennis ball straight up in the air. the height h of the ball in meters at time t in seconds given by h of t equals negative 5t squared plus 5t plus 2. Will the ball reach a height of 4 meters? To see if h equals 4 for some value of t, set the quadratic equation or expression for h equal to 4 and solve. So again, we want to know a height of 4 meters. So h equals 4, or really h of t equals 4, and that's how they got this equation. Then we want to set it equal to 0, so we subtract 4. So we're ending up with negative 5t squared plus 5t minus 2 equals 0. We have a, b, and c there. The discriminant is our b squared minus 4ac. I'll rewrite it so we can remember. So when it's all said and done, we get a discriminant of negative 15. So we have two complex or imaginary solutions. Well, if they're not real, then we have no solution to the original equation. So h can't be 4. And that's what we're saying here. So really just kind of don't overthink this one. Just make sure you know what h and t are, and really all equations. What value of b will cause 2x squared plus bx plus 18 equals 0 to have one real solution? For this equation, a equals 2, c equals 18. Obviously, we can see that from the equation. So we plug in a and c, and if we're getting one real solution, that means our discriminant is 0. That's how we get one real solution. So b squared minus 4ac equals 0. We substitute in a and c because we know those. So we get b squared minus 144 equals 0. We can add 144 both sides and take the square root. So b equals plus or minus 12. So there's actually two equations that work with that. 2x squared plus 12x plus 18 and 2x squared minus 12x plus 18. There's still only one solution, but there's two different equations. This would have a solution of negative 12. This would be 12. Or not solutions. Those are our b's. So two equations, they each have one answer. And just to summarize, x is negative e plus or minus square root of b squared minus 4ac, all divided by 2a. You need to know this formula. If you don't know this formula for our test, it means you haven't been doing your work, and we need to try that again. So, predict the number and type of solution to the discriminant value. Again, discriminant that's positive, we have two solutions, two real. If it's 0, we get one real solution. And if it's less than 0 or negative, we have two non-real solutions. So that is how we use our quadratic formula.